Okay, so let us solve this question, then I can conclude my lesson. We are having a power plant provides 1 megawatts of power to a town. The power lines, they have the total resistance of 0.5 ohms. Then calculate the loss of power as heat within the power lines without step-up transformer if the power is generated at 100 volts. Also, if now we change the setting, now suppose we use a transformer to increase voltage from this this is 1000 volts, from 1000 volts to 100,000 volts. Calculate the power loss. How do we have the power loss as heat? You know that whenever electric current passes through a conductor, there is a loss of electrical power as heat given by a formula. H is equal to I square times R. Power is equal to power loss is equal to I square times R. So here we say that data given, electrical power produced, electrical power is 1 megawatt, which is 1 to 10 to 6 watt joules per second. We are also given that the power is generated at this volt, so potential, electric potential of the power, electric potential V is 1000 volts. So we are supposed to find what is the power loss. Power loss is how much? The power is lost through the wires when the electric passes through them, which is given that from power is equal to IV. So if the plant is producing power at this much, 10 to positive 6 watt, and we are given the potential is 100 volts. Now we need to know what is the current. We have the power, we have the volts. So we need to know what is the current that is passing through the electrical wires, which are most of the time are copper wires. So here we say that from this one, it means that power divided by V, you can get the current. Current is, you take the power 10 to 6, then you divide by 1000. So you see the current here is 1000 amps. So the current that is passing through the electrical wires is 1000 amps. But the power loss is given by I square times the R. The power which is lost as heat, it depends what is the amount of the current passing through the wire times the resistance. I square times resistance. So the power loss, it is I square, 1000 square, times the resistance. What is the resistance? Sorry, I forgot to record this data here. If you can, resistance, the resistance of the copper of the wire, it is 0.5 amps. So we multiply by 0.5 amps. If you multiply here, you find that power loss is almost 1 million times a half. That will be 5 watt. This amount is too large. Can you imagine? You produce a power at 1 million and half of it is lost as heat. This loss is too much. So we cannot afford that. We cannot afford that. So that is the scenario without step-up transformer. Let's see what happens if we use the step-up transformer. Maybe we are at the point to see the applications of transformer.